Okay, so hey guys, it's Quinston, and today we are going to talk about the jump search. Now, the jump search is a pretty interesting algorithm. It is kind of the linear search mixed in with the binary search of sorts, and it's pretty simple to understand. So what it does is it creates blocks of the array and basically determines whether your number fits inside that block. And if your number fits inside that block, it basically goes ahead and does a linear search inside the bounds of that particular block and finds your number. Obviously, in order for this to be, a valid way of searching, you have to first sort the array in either ascending or descending order. In this case, we're considering an ascending order, but yeah, it's pretty interesting. It's creation of blocks, and then traversing those blocks throughout the entire array and then finding a block which fits your number and then traversing that number. So the way we do this is here, as you can see, we have an array called L. It's a very fancy name, L, and L dies, by the way. And yeah, I mean, you have this array which is like a bunch of numbers and everything, and you have the length of the array, which I've calculated by taking the size of the entire array divided by the size of one element, which basically gives me the length of the array. That's a mathematical formula which we use to find the length of an array in C++. This is C++. So yeah, then you have int key. Key is basically going to be the value inside the array that we want to find the position of. So basically we want to find the position of, in this case, 34 inside the array. So where is 34? Over here. So what's the position of 34? 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. So basically the output of this program is supposed to be 9. And here I've basically created a jump search call. I haven't written the jump search function because we're going to do this in this program. And yeah, so basically what I've done is I've taken jump search, I've called L. L is the length, L is the array itself, length and key. All of these strings are 3 parameters. I'm passing into the jump search algorithm, a jump search function, and basically it will give me some value which I store in X, and then X I'm comparing with -1. If it's equal to -1, which means that the number doesn't exist, the key doesn't exist inside the array, and if it is not equal to -1, it basically means the key exists. Basically, X cannot be less than 0 because in arrays, array's index cannot be less than 0, so -1 is the perfect candidate to use over here. Maybe in different programming languages it might not work. In C++ it does, so good job. So the first thing is we need to define the size of our block, right? The bounds, the initial and the final bounds of our block. So basically what I'm going to do is I'm going to say int left is equal to 0 and int right is equal to sqrt of length. And you might be wondering, hey, wait a second, Quinston, what is this? Why are you saying left and right? Because left and right are going to be my bounds, and then I'm going to shift those bounds and traverse the entire array. That's what I'm going to do. I'm going to basically define a set of bounds, and then I'm going to move those bounds from one place to another in order to basically incrementing those bounds to find the value. So that's what we are doing over here. SQRT because sometimes you might have length which is variable, and then you don't want to adjust your bounds relatively. If you have and in most cases I checked a lot of blogs online, they all said that SQRT is the most optimum with the double quotes block size to be used. So that's what we're going to use. We're going to use the block size of SQRT, which is the square root of length. SQRT is a function which we get from the CMath library, which we have included over here. So if you want to use SQRT, you will have to include this library over here. Everything else is pretty standard. The next thing that we want to do is we want to check which block the number or the key is going to be in. So for that we use something like an if statement, and basically what we're going to do is if L of right, L of right is less than or equal to the key. What does this mean then? If L of right is less than or equal to the key. So L of right, what is L of right? Right in this case is SQRT of length. So L of SQRT of length, let's say SQRT of length is 5, right? So L of 5 will be 0, 1, 2, 3, 4, 5. Is this one? Is this number over here? So L of 5 is this number over here. If the key is less than or equal to this number, it means that it's in the first block or is in the block which is preceding it. So is our 34 in this block? No, right? 34 is not in this block. But if it was, we could do something about it. And we have to check one more condition, that if right is less than length. Now, the value of right now is pretty big. It's 5 right now, but it can be 10, it can be 20, it can be 30, it can be 40. we always want the length to be, greater than the right value, because hey, we don't want the right to be outside the array, and when you're traversing it, you just you basically go outside the array, and then you get like a segmentation fault. We don't want that, in our program. So basically what we do over here is we have right less than length, and when we basically calculate that, you'll realize what we're doing over here. So if this value is true and this value is true, basically we can go forward, and we basically know in this case that, hey, this is not the right block. So we know that this is not the right block, why can't I write E? Not the right block. So if it is not the right block, you basically do left is equal to right, okay, and right plus equal to sqrt of length. And you might be wondering, hey, wait, what are you doing over here? And I will tell you that, hey, what I'm doing is I'm taking the value of right and giving it to left, because now I want to shift the block, right? I want to shift the block. So if my initial block was still here, I want my new block to start from here. And that's what I'm doing here. I'm giving the value of right to left, and then what happens is I'm just incrementing this by the square root of length, or the value of right. So basically the right also shifts and the left also shifts by the same value. So it's pretty simple. It makes sense. What you could also do is just write plus equal to sqrt of length, but I thought this was more intuitive, so that's what I wrote. Next, what you want to do is if right is greater than length minus 1. So if right is greater than length minus 1, let's think about what this means. What does right greater than length minus 1 mean? What is length minus 1? Length minus 1 is basically the position of the last element of the array, right? It's the position of the last element of the array. But when you do right plus equal to sqrt of length, what happens is you might exceed that value. Right should always point to an element, right? Right cannot be pointing to something else, or it should at least point one more than the element. It cannot be greater than by a margin. So what you do is you just write right is equal to length, and once you do that, everything is sorted and everything works out. You will understand why I said length over here and why not length minus 1. Let's check why that happens. So once you solve this part over here, what you're going to do is you're going to write a for loop. So at the end of this, you're going to say you're going to be in the right block. We have the right block. Once you finish this, we have right block. But you might be wondering, wait a second, we have only executed this once. Exactly. This is going to be while and not if, because we're going to do this continuously until we find the right block. And now we have it, right? We have the right block. And what we do now is basically just go through the array. So I'm going to write for int I is equal to left, I is less than right, and I plus plus. And once we do that, we say if L of I, not P, is equal to key, and then return I. Now if I run this, you see that the value is 9, right? We got the answer. It basically works. So what we did over here is we basically found the right block after executing this a multitude amount of times, while again and again and again until we find the right block. And once we found the right block, we basically just, traverse from left to right, less than right. So you might be wondering, if it's equal to length, it's going to be less than right, because, right might be equal to 1 plus the last element. And that's how we get this value. So yeah, I mean, if you write like 610 over here, it basically would work just as well, and you get the answer 15. Yes, it works just as well. So yeah, I mean, the code will be in the description, guys. Thanks for watching. I love you, and yeah, maybe I got a little too much over there, but yeah, thanks for watching. I appreciate the love, and like, share, and subscribe to the channel, because I put out videos whenever I find time to make them. I love making these videos, but I'm just so caught up in other stuff right now. I'm running a business and everything. So thanks for watching, guys. I will see you in the next one. Peace.